Chapter 15 is about scheduling. Okay, if we have a plan next month, next week, next year, like that, and next month, 1,000. Then more detail assigning. First week, then many, second week, then many, and then who will do. Yes. So assigning, that is scheduling. Assigning specific tasks, jobs, and work for and so on. And then time. First week, second week, or first day, second day, and so on like that. And providing detailed instructions. Converting the production plan, like a monthly plan, to weekly or day-to-day. Objective. Meet due date. Okay, this class, you don't have assignment, homework. But if this class is online, then I give homework every week. But in class, fortunately, no homework. Okay, homework, assignment, due date, right? So, if I know how long it takes, then due date. If it takes like 2 days, then at least 2 days earlier I start, right, to meet the due date. So scheduling, meeting due date. Minimize lead time. Okay, lead time from the time between order and then receive. So if we schedule well, then lead time is short. And setup time was cost. Earlier, I told you if we schedule change, like a type A, B, then 1, 2, 3 setup time we need. But if we schedule A, B, then only one setup time. Minimize setup time. And then minimize working process. You know working process. Schedule well, then we can reduce the inventory. And then maximize machine utilization. Schedule today 1,000. This month 1,000. Next month, like this. This one. First month 1,000. Second month, no. Maybe some. Third month, 1,500. Uneven schedule. That case, for this to meet this demand, this company should have 1,500 capacity, right? Then this one 1,500, 1,500. Capacity here. Utilization rate is too low, right? If we can schedule like average 1,000, 1,000, 1,000, then it need only 1,000 capacity. Save money, the cost, and then utilization rate is high, like this. So scheduling well, then those objectives meet. And capacity and scheduling. If capacity here, just doesn't matter about the capacity, just schedule. Lower, just to do. over the capacity just to do, and then carry over something like that. That is infinite loading. The finite loading always schedule under the capacity. And forward and backward scheduling. You know, make to stock system, make to order system, right? Make to stock and make to order system. For the scheduling each operation when system takes on order. When take order, then start. That is make to order system. Make to order system. Products are the known and product demand is unknown. Future demand we don't know. Just receive actual demand, order, then start, right? So if there are some stages in process, then material flow this way. This is customer and then supplier. Then we call this upstream and downstream, right? Then, because this company doesn't know future demand, they don't know, so wait. Then receive order, then this one doesn't have a part. Ask part, and so on like this. So, they don't know when receive part from a supplier or upstream, so they cannot schedule. Then this one come, order, and then a part come, and then they know when it's done, right? So schedule this one first, second, third, and fourth, and like this. So after receiving part, they know when customer can receive, right? So schedule this one. From upstream to downstream, the order scheduling from upstream to downstream, forward. So if the system is make to order system, then forward scheduling. Okay, next, backward scheduling. Production activities are scheduled by their due date. They know future demand. And then produce. We need 1,000 next month. We know due date, right? Then they know how many days they need. So to meet due date, like a homework. To do that homework, if we need 2 days, then 2 days early we should start, right? So due date, we know due date, schedule this one, schedule this one, schedule this one, schedule this one, and schedule like this. So schedule this way, material flow this way, upstream, downstream, backward, right? So if the system, a system is make to stock system, then backward scheduling is better scheduling method. And machine limited, labor limited. If machine hour is limited, that is kind of capacity. So about that schedule, about machine limited. If labor is limited, then about that schedule. So resource can be something like a restriction when you schedule. Job sequencing. The process of determining which job to start first on some machine or in some work center. Okay. Sometimes when you take midterm, final, or something standard test, usually we solve problem by number, right? First one, second one, third one. But sometimes you stuck certain problem and then then you cannot do rest of the question like that. Then suggest skip that one first, and then if you have time, then come back like that, right? Like that. If you have multiple works, maybe you use just order, first one, second one, third one, and so on like this. But sometimes change order, sequencing. Then you may make something faster or cheaper and like that, right? That is job sequencing. If you have multiple works, then which one first, which one second, sequencing. First rule, by order, first come, first serve, right? Number one solve, number two solve, and so on like that. First come, first serve. And SOT rule, run the job with the shortest completion time first. If we have multiple works, then this one may take 5 days, 3 days, 1 day, 2 days like that. Then shorter one, shortest one, 1 day job first, 2 day job, and so on like that. So sequencing by working time, that is SOT rule. And select time remaining. Select time is time remaining before due date. Okay. Like homework, multiple homework you have. Then closer due date, homework first, second, and so on like that. That is time remaining. So STR, shorter, due date remaining, first, second, third, and so on like that. And STR, select time remaining. Remaining time to the due date divided by operation time per operation, and then shorter the result, first, second, third. And due date, closer due date first and second and so on. Critical ratio, using critical ratio, due date minus current date. Due date is next week, 7 days later. Today's date is 13. 20, due date 20 minus 13 divided by how many days for the job, operation time. Then shorter one, first, second, and so on. And last come, last serve. We don't use this one usually, right? First come, first usual, not last come, last. And then random order, just to keep randomly. Among those rules, compare using example. If there are 5 jobs, job A, B, C, D, and so on, then processing time, operation time is 3 days, 4 days, 2 days, 6 days, 1 day. Then due date is 5 days later, 6 days later, and so on. If we use first come, first serve rule, A first, B second, and so on, then flow time, total flow time, because they have the sequence A finish, then B start, and so on like that. So start from 0, use 3 days, so finish 3. After this A finish, B start, so 3 plus 4 days, wait 3 days, and so on. So total flow time will be 3 plus 7 plus 9 plus and so on, 50 days. And mean flow time, total flow time divided by how many? So 10 days. On time job, due date is 5, finish at 3, so meet the due date. 6, miss 1 day, 2 days, and so on like that. So 0, 1, 2, 6, 14 lateness divided by 5, average lateness is 4.6. Next, SOT rule, shortest operation time or process time. Among them, job E is shortest, so first, job C second, and so on. Then total flow time is 36, mean flow time is 7.2. On the meet the due date, E and C, miss the late A, B, D, and average lateness is 2.4. So use some rules like this and compare their time. Total flow time, FCFS 50, SOT 36, and so on. And mean flow time, average lateness. Among them, shortest operation time, sequencing rule, 36, 7.27, 2.4, shortest, right? So if we can use that rule to do multiple jobs, then that rule make the fastest process. This one always work if we can use that, but usually we use first come first, first serve, right? But if we can use that rule, then that is the shortest, always. Okay, next. Scheduling n jobs on 2 machines. If when I make copy your lecture notes, staple. This one stapled, right? We have, department has copy machine, then punch and automatically staple, convenient. When I went to Hanoi, Vietnam to teach the same class, operations management, then the school, the copy machine doesn't have that function. Just make copy. So later, I use stapler myself. That time, 45 students. And then the copy machine was very slow. So for one class to make one lecture note, usually it took 30 minutes, including a stay. Okay. If I'm not kind, then I didn't staple for students. Then just copy and then give students, then they can have right. But I was kind people, person. So staple. Okay. If there are two machines, copy machine and stapling machine, then first copy and then this one go next like this, right? Two machine. If we need complete something, like two jobs we need, like copy and then staple. And then multiple jobs. For this class, for that class, if I have multiple classes, then 30 students, 45 students, and so on like that, then copy and staple. That case, scheduling, which one first, which one second, to make faster. Okay, we call this Johnson's rule, minimize the flow time. Step one, list like this. Job A needed 3 time unit for machine 1 and machine 2, 2. B, job B needs 6 and 8 and so on like this. Okay. Then, step 2, select the shortest operation time. And then, if shortest time is for the first machine, do the job first. If it is for the second machine, do the job last, and then repeat. I will show you. Okay. Operation time 3, 6, 5, 7, 2, 8, 6, 4. Among them, this one is shortest, right? Take that one. Okay, first machine or second machine? Second machine. So do the job A at last. It is for the second machine, do the job A last. So place A last. Then A is gone, B, C, D. So operation time 6, 8, 5, 6, 7, 4 remain. Among them, this one is shortest, right? 4 is shortest. It is for the second machine again. So do the job D, second last. Place job D here, second last. Okay, now job A is gone, job D is gone, B and C remain 6, 5, A, 6. Among them, 6, 5 is shortest, right? It is for the first machine. So do the job C first. So place job C first. And then so sequence job order is C, B, D, A. Okay. Complicate or just you can do. So with this order C, B, D, A, job C go machine 1, take 5, and then after finish B goes machine A, but job C goes machine C, and so on. The total time is 25. It should be the shortest processing time. Okay, practice problem is attached. This one. Try. Try. Ah, not attached. I made separate.
We looking for it, huh?
Sorry.
Well, I might need it.
Something heavy. Try. Better view, right? Nine six eight five seven seven six three 1 2 2 6 4 7. One. This one is shortest, right?
Right.
First machine, right?
Right.
Number 5.
Right.
Job number 5 goes first, right?
All right, I got that.
Good. Cross out. Okay. 9, 6, 8, and so on. 2 is next is shortest, right?
Yes.
First machine again.
Yeah.
So job 6 goes here.
All right.
Okay, cross out. Next shortest one is 3, right?
Yep.
Second machine, so job 4 goes
Last.
last, right?
Yep.
Cross out. And 4,
Yep.
this one is next shortest, first machine. So job 7 goes
Yeah.
gone. Then 5 is next shortest. So job B 2. This one second machine. So go
2.
2, right?
Yep.
Gone. And 6. This one is next shortest. So job 1, second machine, last, right?
Yep.
So 1, and then 3 is the last one, 3 here, right?
Yep.
So 5, 6, 7, 3, 1, 2, 4.
Bingo.
Go. Good?
Good.
Oh,
Easy.
very easy.
For you to say.
Question? Good. Okay, now next one. Maybe easy, but maybe very hard, very complicated. So open your eyes, hold tight, and follow me, okay? Scheduling a set number of jobs on the same number of machines. Earlier, Johnson's rule, multiple jobs but only 2 machines, right? But this one, same number of jobs, same number of workers, like, okay. There are 5 workers and then 5 jobs. Which one assigned to which one? To make faster, cheaper, like that. We call this assignment method, a special case of transportation method of linear programming. Earlier, when you talk about location, then I told you briefly about the transportation method. Same number of source or supplier to destination match. How can we make faster? How can we make cheapest? That is transportation method. This one is assignment method, similar. same number of works, same number of workers. There are n things to be distributed to n destinations, same number. Each thing must be assigned to one and only one destination. So match one by one. And only one criterion can be used, such as minimize cost. Try to minimize cost. If there is a cost problem, then minimize cost. If it's profit problem, then maximize. Or something time. Try to make it minimum time, process time. Among them, use only one, okay? Next example. Clear. Step 1, anyway, there are 5 machines and then 5 jobs. Same number, 5 and 5. Step 1, subtract the smallest number in each row from itself and all other numbers in that row. Row is horizontal, right? On the first row, smallest is 3. Smallest 3. So it says subtract the smallest number in each row from itself and all other numbers. So minus 3, minus 3, minus 3, minus 3, and minus 3. The result will be five minus 3, 2, 6 minus 3, 3, 4 minus 3, 1, 8 minus 3, 5, 3 minus 3 is 0. And then next row, 4 is smallest. 4 is smallest. So 6 minus 4, 4 minus 4, 9 minus 4, 8 minus 4, 5 minus 4. Then result 2, 0, 5, 4, 1. And then next row, next and next. So smallest on this row 2. Next row 2. Next row 3. Subtract 4 minus 2, 3 minus 2, 2 minus 2, and so on. 7 minus 2, 2 minus 2, 4 minus 2, and so on. 3 minus 3, 6 minus 3, and so on. Then result is like this. This is first step. Too dark to see? Is it okay?
Okay.
Okay. Question so far? Doable? Okay. Next step. Subtract the smallest number in each column. Column is vertical. Okay. So first column, second column, third column, and so on. Okay, look at this first column. Smallest is 0. It doesn't matter, right? Smallest is 0. 2 minus 0, the same, right? Second row, 0. Third row, 0. Fourth row, 2. 0. So, only this column change. Others remain the same. So 5 minus 2, 5 minus 2, 4 minus 2, 3 minus 2, 3 minus 2, 2 minus 2. Other columns the same, remain the same because smallest is 0. Only this column change. 3, 2, 1, 1, 0. Okay, so far. Are you with me? Okay. Then step 3, determine if the minimum number of lines required to cover each 0 is equal to n. This case, n is 5 because there are 5 columns, 5 rows. If so, an optimal solution has found. If the minimum number of lines required is less than n, less than 5 this case, this example, then go next step. To cover zeros using line, either way, column or row, if you find 2 or more zeros, cover that column or row first. This column only 1 0, right? This column there are 2. Cover this column first, like this. Next column only 1 0. Next column only 1 0. Next column only 1 0. How about row? Only 1 0. Only 1 0. Only 1 0. Only 1 0. There are 2 zeros. Cover this row. Keep in mind, look at column or row. If there are 2 or more zeros, cover that column or row first. Okay? After that, this column already covered by this one, this line, so it's okay. This one remain, right? It doesn't matter if we use vertical or horizontal line, like this, like this, like this, like this, it doesn't matter. Cover, cover. I used 4 lines, cover all zeros, right? Or use horizontal like this. Horizontal or vertical doesn't matter. After you cover 2 or more zero column or row, then if only one zero column or only one zero row, it doesn't matter using vertical or horizontal. Anyway, you can cover. Do you know what I mean? Okay, so the most important thing is cover if there are 2 or more zeros on column or row first, and then 1 0 column, 1 0 row. It doesn't matter using a vertical or horizontal cover. If so, I use like this, and then it doesn't matter to cover only 1 0 column or row. It doesn't matter. Then anyway, the number of lines required to cover all 0 is 4, right? So n is 5. N is 5. The minimum number of lines to cover all 0 is 4. Less than 5, right? So not yet. Not yet we can have optimal solution. We need one more step. Step 4, subtract the smallest number not covered by lines. Not covered by lines, 2, 2, 5, 1, 5, 2, 3, 2, 1. Other numbers covered by line so far. Among numbers not covered by lines, 2, 2, 5, 1, 5, 2, 3, 2, 1. Smallest is this one, 1, this one, 1. Subtract the smallest number not covered by line. Don't touch numbers covered by line. Just subtract smallest number from not covered by line. This one is making more 0. Making more 0. Then result will be, after subtracting smallest number not covered by line, then change like this. 114042110. Don't touch numbers covered by line. Okay, next, try again. Cover all 0 by line. I told you 2 or more zeros on the column or on the row first. So I will use something like this. To cover all zeros, I need 5 lines. Minimum number of lines to cover all 0 That is 5 now. So the number of lines equals n, 5. The same number. So now we can find optimal solution. Optimal solution. The minimum number of lines equal to cover all 0 is 5. It is equal to n equals 5. The solution will be optimal. Okay, how can we find the solution? Zeros like this, right? On this job 1 has 2 0 on C and E.